Alright, this video is about solving systems, linear systems, by elimination. So there are several different ways you can solve a system. You can solve by graphing, by substitution, or by elimination, which is what this one is about. So I'm going to give you a system to start with. So that means you're going to be given two equations. And ideally, if you're working to use elimination, you want those to be in standard form. That's the ax plus by equals c form. And what I mean by that is that the x and y are on the same side of the equation. So if I have these two equations, if this is my system, then what I can do is I can think of this as adding or subtracting the two. I prefer to add. Subtracting sometimes confuses people with the negatives. So, but in order, what I want to happen is when I add the two equations together, I want to eliminate one of the variables. That's why it's called elimination. That means I want one of the variables to cancel out. Well, the only way they're going to do that is if they are the exact same thing, but one positive and one negative, if they're opposites of each other. So if I have like a 2x and a negative 2x, 2 plus negative 2 is 0. Or if I have a 3 and a negative 3, or a 4 and a negative 4, or whatever. So I want to look for that to happen. And so if you'll look at this example that I've given you, you'll notice that I have a negative y and a positive y. That's a negative 1 and a positive 1. And so if that's what I've got, then when I add these together, those variables should cancel out. So that's what I'm going to do. So I'm going to add my two equations. I'm adding the x's, adding the y's, and adding the constant terms. The constant terms are the plain numbers. Okay, so x plus x, remember that's a 1x plus a 1x, so that makes this 2x. Negative y plus y, or negative 1 plus 1, that's 0. So this part cancels out. I don't have a y anymore. And 1 plus 3 equals 4. So now I'm going to go ahead and divide to solve for the x. And this becomes x equals 2. So just like we're solving using any of these methods, ultimately I'm looking to get an ordered pair in most cases. And so what I've found is I've found that the x value is 2. But I still need to know what the y value is before I'm finished with this problem. So I'm going to take this 2 and I'm going to plug it back into one of the equations that I had before. Okay, so I'm going to use this second one. But you can use either one. I'm just choosing to use the second. So I'm going to put the 2 in place of the x. So that's going to make it 2 plus y equals 3. Subtract the 2 to solve for y. And I'm going to get y equals 1. So my ordered pair, or my solution here, is 2, 1. Now remember, if I were graphing these, what would happen is if I graph these two lines, the point 2, 1 is where those two lines would intersect. Okay, so let's try another one. Alright, so I've got x plus 4y equals 11 and x minus 6y equals 11. So if you look at this one, I'm first looking to see if I have two variables with the same number but opposite signs. So I can see that my x's, they're both a 1x. It would really be helpful if they was a 1 and a negative 1. So we're going to make that happen. I'm going to take my first equation and multiply it by negative 1. So that's going to be negative 1 times all of the parts. That'll make it a negative x minus a 4y equals a negative 11. I'm going to leave my second equation alone because now my x's are just like I want them to be. So I'm going to add those two equations together. Negative x plus x is going to make 0, so my x's are canceling out. Negative 4 plus negative 6 is negative 10y. And negative 11 plus 11 is 0. Divide by the negative 10, and I get y equals 0. It's okay to get 0 as an answer. That happens sometimes. 0 divided by something is 0. So remember, I want to find my x's and my y's. So I've got to take this value and plug it back into one of my equations. I'm going to put it back into this second equation, although I could have just as easily used the first. So this is x minus 6 times 0 equals 11. 6 times 0 is 0, so I get just x equals 11. So if I put that x and y value together to make an ordered pair, my solution is 11, 0. Alright, let's look at another one. So now I have 2x plus 5y equals 3, and negative x plus 3y equals negative 7. So that's my system. And you can see that I do not have the x's with the same number or the y's with the same number. So I'm going to multiply. So what I'm going to do is multiply my second equation in this case. I'm going to multiply it by 2, because if I multiplied it by 2, that would make this a negative 2x, which would work nicely with that 2x. So I'm going to leave my first equation the same this time and multiply my second equation by 2. So that's going to be negative 2x plus 6y equals negative 14. And now I'm going to add those together. So the x's are going to make 0. 5y plus 6y is 11y. 3 plus negative 14 is negative 11. Okay, so that is going to give me negative 11 divided by 11 is negative 1. Right, now I'm going to take that and I'm going to put it back into, I'm going to use my first equation this time. Remember, it doesn't matter, just pick one of the equations, but whenever you plug this number in, it works best, ideally, if you put it in parentheses. So that's going to be 2x plus 5 times negative 1 equals 3. So I just put the negative 1 in place of y in my first equation. So that's 2x minus 5 equals 3. Add the 5. Divide by 2. And x equals 4. Now put my x and y value together to make an ordered pair. So 4, negative 1 would be my solution. Okay. All right, so let's look at one more. I have 2x plus 3y equals 14, and 3x minus 4y equals 4. So if I look at this system, remember I want either my x's or my y's to be opposite numbers, and they're not close this time. So what I want to think about is, if I just look at my x's, okay, if I just look at the x's, I have a 2 and I have a 3. Okay, so think of the smallest number that 2 and 3 could both go into. I could make both of my x's be 6. Okay, one of them a 6 and one a negative 6. Or if I wanted to do the y's instead, I have a 3 and I have a 4. So think of the smallest number that 3 and 4 both go into. That would be 12. I could make them both 12. The choice is up to you. It will work either way. Okay, just since 6 is smaller than 12, I'm going to do the x's instead. So I need to think to myself, what do I multiply times 2 to make this a 6? Okay, so we'd have to multiply 2 times 3 to make this a 6x. So I'm going to do that. That would make my first equation 6x plus 9y equals 42, because remember that 3 is times everything in that equation. All right, now the second one starts with a 3. So what do I multiply by the 3 to make it a 6? So the second equation, I'm going to have to multiply it by a 2. But not only a 2, I really want it to be a negative 2, because I need a negative 6 to add with that positive 6 I already have in the other one. So that's going to make this a negative 6x plus 8y equals negative 8. So now I'm going to add my two equations together. 6 plus negative 6 makes that part 0. 9 plus 8 makes this 17y. And 42 minus 8 is equal to 34. Divide by 17. And y equals 2. I'm going to take that 2, plug it back into my original first equation. So that's going to be 2x plus 3 times 2 equals 14. Or 2x plus 6 equals 14. Subtract the 6. So 2x equals 8. And divide, and we get x equals 4. So if I put those two together, my ordered pair, that is my solution, is 4, 2. Now, just one note here, I'm not going to do a whole problem like this, but the way that you would recognize a no solution or an infinitely many solutions. So, no solution would be if I had two, and when I add them together, I get something that is not true. So like if I add these together, I'm going to get 0 equals 14. That is not true. So that would be no solution. If I got something that was true, like 0 equals 0, then I would say infinitely many solutions.